Greetings, this is Edward Ojambo. In this tutorial, I'm going to show you how to train an AI. We're actually going to be training one called GPT-Neo. It's a 125M model. Before we I also want to remind you that you should subscribe, like, follow, and leave comments for more frequent content. I'd like to thank everybody who subscribed so far this month. Keep it up. It inspires me to make tutorials just like this one. Alright, now just need to set up a little bit here, but that should be neither here or there. We can simply continue. So basically we're going to use obviously Podman Compose, and what we're going to do is basically a quick reminder that small LLMs, that's large language models, are usually used to train bigger models. So for example, it's a good way for yourself to get started into AI training. So the good thing about training the smaller models like this one, which is only 125M, is that you'll be able to train it on lower spec devices. For example, you can do this on like a Raspberry Pi or a laptop. You don't need a GPU is what I'm getting at. So obviously, and also you'll be able to reproduce results pretty quickly, and you can also use your own custom data set. So yeah, I believe in the last tutorial or the previous one, when I did a training one, somebody asked about where they could get data sets, and I gave an example. They can get them from Hugging Face. Obviously there's some in GitHub. Just look at the license to make sure you're allowed to download and use it. Usually they have some restrictions, so that's why I prefer to use my own custom data set, because normally I want it for my own specific needs. I gave an example, I believe in the last tutorial. I was saying that one of the projects I do have is I built a chicken hoop coop. And what I would like to do is I like to set up some cameras, but I want to set my own algorithm. So for example, if a fox comes by, it could be a hawk or an owl, my algorithm will pick them up because they're different from obviously humans and chickens, and then make a sound and basically also alert me. So obviously this will be running when I'm obviously at home. Or around. If I'm away, obviously that makes no sense, but when I'm there, just to alert me something is wrong. For example, like right now I'm doing a live stream, I might let the chickens out, and then that way I'll be able to stop the live stream and simply go check on them, or just give me a heads up because I need to change, especially like in winter. Alright, so what I'm saying is that I have my own particular use case or needs, so I want to train the AI for my, I guess you call it selfish needs, which is perfectly fine. So we're going to use Podman Compose. The reason I don't use Docker is because Podman is rootless, meaning that I don't need to become a root user or super admin. I think that's what they use in Microsoft Windows. So by doing this, it'll be easy to replicate. For example, some of you guys may be running a remote server, it's a shared server, so you could ask the hosting company to simply install Podman, and you'll be able to run this as well. So it's easily replicable, and everything is easy to containerize into a container or containers. So you also be able to reproduce and build the training environments like I'm using today. You can mount volumes for data, model caching and output, and you can avoid polluting the host system. That's another reason I like using containers. Is, for example, when you're running Python, I'll give you an example. If you have a GPU, to pick it up and try to run everything on the GPU. So the problem, it's going to get loads and loads of, usually it's NVIDIA. It's going to get all the NVIDIA drivers, the dependencies and all those things. It's really annoying because it's going to build something. It gets so much data, and it's just going to build something that's actually much smaller. So, and then because of that Python stuff, especially when you use pip, one of my annoyances with pip, actually pet peeve with pip, is that it installs all these things, but there's no easy way to uninstall them. There are some tricks you can do, but it basically pollutes so much, and you have to fight to find out. So everything in a container is just much more easier. I'm also going to show you how to, I found a trick which I'm going to share with you guys, where you don't have to install so many containers and anything. I'll show you how to actually install. One container will basically have everything you need, and you don't have to go pull up. It's a little bit overkill, but it's much easier than building from scratch. Now, if you want to build from scratch, you can still do it, but I prefer this method because it just made life easier. Okay, so with that said, let's actually get started. So what I did was I created a folder here called training, and inside the training you see I have what I did was I have a data folder, I have a cache folder, and I have an output folder, and then I have my Podman requirements. So and then my testing, and then the training Python. So we're going to go through all of this. Don't worry, I'll show you how to do all this. So the first thing we're going to do is you see the folder structure. So what I did here is, as you can see, we have you have the data folder, we have the output folder, we have the cache folder, and then we have a Docker file, we have a Podman YAML file, we have a requirements.txt file, we have the test.py and train.py file. So I'm going to open all of this up, and then you guys will be able to see what they all look like. So let's start with this very simple one. Let's go to the cache folder. So this, you see how it's a Hugging Face, and these are the data set. So when basically the first time the model is downloaded, it's going to go into the cache folder. So this way it will be faster the second time you run this, so you don't have to run it multiple times. It just simply it will cache in there. And then the data, obviously we have our custom data set here. So I'm going to open this up. Basically the data is going to be just so I'm going to open this up. So what I need to do is, I don't know how many text editors I have open. I'll open up in this text editor. I was doing some other stuff here, so let's close all of those up, and I'll show you here. So my custom data set is very, very simple. I just have two prompts, if you will. The first one is, who is the mayor of Toronto? If you know, I've been testing this question and all the AIs, and all of them have been failing. So the response, it will say, as of 2025, the mayor of Toronto is Olivia Chow. So nice and simple. And then the next question I always ask the AIs is, I need a PHP code snippet to connect to a MySQL database. Now, this one, some of them do fail. The weird thing is the smaller LLMs, they're way more accurate. So this is the answer. As you can see, just PHP MySQL improved, and then it says new and localhost, user, password, and database. So obviously you can make it as big as you want. I just prefer to make it small. You see, I left it in JSON format. The reason I left it in JSON format is simply because I can easily parse this. Or for example, I can generate this for maybe like a SQLite database or something as well. So I just want it to be human readable and easy to modify. So I could also do the text prompt. The problem with the text prompt is that if my data set gets a little bit big, it'll be a little hard to search. So this is much more easy, because I said I can also, for example, if you put this in Firefox has a really pretty prettifier for JSONs, and it's pretty easy to read as well. So that's another reason I did that. Okay, now with that said, so that's our custom data set in the data file. The next one we have is, we have our output, and the output, what will happen in the output folder is that, so remember, it's going to copy the model, the base model, if you will, and then in our output is where it's going to output all our testing. So this way, when we run this, it will give us an accurate answer, if you will. It will give us the answer that we do need. Okay, so what else do we need here? So I'm gonna delete some of these files, but don't worry, it will recreate them. So do not worry about that. We'll recreate them when we do the testing. I just want to run this just to show you what it actually will look like. Or to save time, if this is taking too long, I might just leave what I've done so far, and I'll show you how to run this as well. Okay, so Next, I think we can actually go back and we can actually now open our Docker file. Yes, so we're going to open up the Docker file. So I'm going to drag this and drop it into the here. So I'll zoom in a little bit so you can read the Docker file. So as you can see here, this is the trick. What I'm doing in the Docker file, you see NVCR, that's from NVIDIA. So that's NVIDIA, so I'm getting the PyTorch version 24.05, and obviously it comes with Python. So this is going to save you a lot of time, because when it detects you have a GPU, so for example, I have my GPU is has a GTX 950. It's only 2 gigs of VRAM, so it's obviously not, it's useless for AI training. However, and I do not want to use it for AI training, but however, whenever I run this, it will detect it, and it will attempt to download the NVIDIA drivers, and I said they are gigs upon gigs. I think it's like 100 or 200 gigs. So I don't want it to do that, because I know it's not worth it using my GPU. That's why I always use CPU for now. When I get a slightly beefier GPU, maybe like 12 gigs or something like that, I've been looking, but the prices are ridiculous. They're actually more expensive than they were last year, so it's not worth it right now. So, however, when I get this, the good thing, it comes with everything built in, so I don't need to build them. That's why I like this. And then we set some environmental variables. I see we cache, so it's going to cache in our cache folder, and all the data sets as well. And then it's going to create obviously the cache inside the container as well in /app. You see the work folder will be /app, and then it's going to copy a requirements.txt file. Oh, I didn't open that up. I'll open that up next. And then you can see it pipe to install everything from the requirements.txt. Basically copy everything there into our container, and you see the command will be train, so it's going to do the training for us. I'll come back to this training one as well. So let's open up the requirements.txt file just to show you what that looks like. So we need transformers, we need the torch, we need the data sets, and we need the accelerate. That's 0.26.0. So here's the key. If you do not specify this one, it's going to use your GPU. If you specify 0.26, what it will do is it will use your CPU. If you don't do that, it's going to if you use a one greater than that one, it will use your GPU if it detects your GPU. So you don't want that, especially if you have an NVIDIA driver. Sorry, if you have a NVIDIA GPU that is not powerful enough, like mine. Okay, so next, so I've shown you the Docker file. You can see here, I've shown you the requirements. YAML file. So let's open up the YAML files. The YAML file can be any name. You can code compose.yaml, YML or YAML. Or you can call it docker.compose or podman-compose. It will find it. As long as you have the word compose in it and YAML, it will detect it. So here it is. It's very simple. I'm using what is it here? I'm using the version 3, and as you can see, I'm using the small LLM trainer. That's just the name. I can call it whatever you want. The name doesn't matter. That's because I tried to use the small LLM and that failed. So I guess I left the name. I should probably have changed that, but that's fine. It does work. And so we build basically based on a Docker file, which also grabs the requirements, attacks, and the volumes. So the data, output, and cache, and then we just run the train. We run the train as well, and that's basically it. I've already shown you the JSON file, and obviously make sure you make those folders, and then then we can run your inference sample, and I'll show you that. That's the test.py here, Python file, and you can see, we'll zoom in here. So obviously we use transformers, the auto tokenizer, the auto models for casual LLM, and obviously we import torch, and then So you see here, so before training, you want to specify what model. So here's so basically, if as you can see here, I can run this test Python file by simply, I can test it before training and after training. If I specify the model, that will be the original model. So obviously, as you guys know, the original model is going to tell me something about 2023, right? So obviously that's wrong, or pre-2023, which is always wrong. And then after training, you see I just put /app/output. That's where the trained model is, and it will give me the answer that I want. So this way we can train the model before and after. So I covered you guys here, so you'll be able to train the model before and after to see if it has picked up the trained model is actually outputting the data that you want. So as usual, we have the tokenizer and the model name. That's why you see this is commented out. So comment out which one you want, so before training or after training. So what I'm going to do is I'm going to actually use the one pre-training to just show you that. So we'll come back to this file because I want to use the original one. You will see the difference. It will give the wrong answer, which is what we want. And then if you have CUDA, so some of you guys most likely are going to have a GPU that's better than mine. So I do have a condition here. You see, if it detects you have a CUDA is available, it will use it. If not, it will just use CPU. So in my case, it's going to detect that the GPU is not available. Then it's going to default to the CPU. And then the prompt is very simple. We ask it who is the mayor of Toronto, and then tokenize, and then it will return the answer for us. Now, if you guys recall, basically every other week I've been using Alpaca because it's an Alma client. Now, last time I showed you, when you open up that client, the settings for Alma. For example, now you guys will understand. I said this will make more sense next time. Now, for example, how many tokens you should use, the samples, the top K, temperature, all this type of stuff. You guys will understand this because it will. You can basically grab those settings which somebody has obviously tested. You can use them and then tweak it to your own. So, for example, you can modify all this. We can modify all these ones. I even comment them here for you to your heart's content and see where you get the best results. Okay, and then after that, we just print out this and it will give us the answer. So obviously, one very important thing as well, you see here where it says prompt, make sure it matches the one in our data set here, the prompt. Oh, not the data set, the way the data is, the training data is actually put inside the it's sent to the LLM. Okay, so this is our test one. Now, obviously, the training one is going to be very similar. So this is the training. It's going to be very similar. Zoom in a little bit so you guys can see. So you can see it's very similar. We have create special tokens. You see, question answer. So meaning that what it's going to do is it's going to grab the question, and for that question, it have a specific answer. So this is just delimiters. So the reason I did this is also so that if sometimes you might just get data as a what do you call it? The data might just be a text file, right? So this way, I decided to make mine a JSON file, but I said you can have different data sets. So the only difference is just send them the same way. So it will know that everything in this delimiter is a question, and everything in this delimiter is the answer. So whatever delimiters you want. In my case, I'm using this pipe symbols to between the questions and answers. And then I created this method. Somebody actually asked me, I think it was yesterday or the day before, somebody asked how they want me to do more Python Python programming, and I told them, I do that all the time. There's AI and there's also Blender. So here we go. As you can see here, so I created this method, and all it does is return the text, the question, and obviously for the prompt, for example, I showed you in the test Python file, and then the answer. And then after that, this is very simple Python stuff. We've done this several times. I think last year I showed you how to do this, how to read JSON files. Pretty straightforward. And you set the map, and then the train, you set the size, and then you can move the columns, prompt and response. And you see the model name. We're specifying what model it is. So this is training the base model. And then after that, we pad the tokens to the EOS underscore token, and then so sometimes it might not exist, so that's why we have this condition. If it does exist, we set it to the EOS underscore token, and after that we get, you see it says from pre-trained, meaning it hasn't been trained yet. So we are training the model that hasn't been trained yet. I want to touch on one little thing here. Okay, so the tokenize here, example text, and the maximum length, truncation, true, and maximum length is 128. So one thing I've noticed is because this model is small, this language model, I had to set this to a smaller size, to 128. I think by default it was 512, and it was always failing. So because it's a small model, you need to set this number to a low one. So I even tried 256, it was still giving me some problems. So I set it to 128, and that seemed to work. You might have to set even lower than that, but 128 is a good it's a good starting point. Another problem is when you use this smaller models, they're stripped down. So a lot of the things which are available on the larger language models are not available on the small ones. The reason for that is this 120? Can it 22? Yes, of course. So Mohit Shah has asked a question, just a question. This is 125M. Can I train it on CPU? Absolutely. I'm training it on the CPU myself. Now, the reason I downloaded the NVIDIA container, or we're going to use the NVIDIA container, is so that if I don't use the NVIDIA container, I'll have to install majority of that stuff anyway. It's because NVIDIA has it's basically a monopoly for AI training. They assume they're going to have a NVIDIA GPU, and you're going to use your GPU. However, they said in my case, my GPU is only 2 gigs of VRAM, which is useless for AI. So I don't want to use it. I want to use the CPU. So that's why, yes, absolutely, you can train this on your CPU, and I'll show you. I'm going to be training it on the CPU myself once I finish explaining the code here. And the good thing about training on CPU is that, especially with something like this one, is 125M, you can train it on a very low spec device, like I just said, like on a Raspberry Pi, right, or another laptop you have sitting around. This will absolutely work on it. Okay, let's continue here. So output, remember we created that output folder, so that's where it's going to put it. And then you can also fool around with some of these numbers here, the training batch and the batch evaluation size, and the number of train epochs, 20, and logging steps, 10. So I want to talk about this for a second. This is actually very, very important as well. The first time I ran this, I was surprised because it says everything worked very well, so I was very happy. And then what happened was it gave the wrong answer. It took me a while to realize that when you train, my assumption was that since the model is very, very small, that I just need to train it one time and then it will work. No, that will not work, because what happens is you have to train the model multiple times for it to pick the answer. So for example, that simple question is, when I ask it, who is the mayor of Toronto? Because I trained it one time, it still gave the old answer, and I was scratching my head. I'm going, what is going on? So the reason for that is because you need to tweak this to let it know that the answer you actually want, or the correct answer, is the one from your custom data set, not from the old one. So that's a trick. You won't read that anywhere. People just say, oh, do this, but they don't explain that to you. So I had to figure that out the hard way, that you need to actually train it multiple times. So if you don't want to do that, obviously, which you don't, you want to train it one time. So change these numbers. You see the number of train epochs, set that to 20. I guess for larger models you can train them maybe 5 or whatever, but for the small ones, you need to set that number multiple times. So don't set this to 1, set it to like 10, 15. And for example, if you get a model that's already been trained, you might actually bump this number up because it's going to think the other answer was correct. So basically, think of it this way: if somebody tells you your entire life that 1 + 1 = 3, right? The first person you meet who tells you 1 + 1 = 2, you're going to ignore them, because for up to that point in your life, people have been saying 1 + 1 = 3. You get my point? So it's the same scenario here, in that you have to like, I guess, repeat the training a few times for it to understand that the answer you're the data set is accurate. Or if you want to give you the wrong answers, you can do that as well. Okay, now with that said, we also have the logs here. You can check out the logs, and then obviously you see this FP16. That's why it says torch.CUDA is available. So it will check. It will set it to false if CUDA is not available. Okay, if CUDA is there, it's going to be, if you have a GPU, it'll be much faster. But you can train this purely on the CPU. Now, I also want to say something. I don't recommend using the CPU for larger models. I tried that. I tried even just a 1.1 gig. That was a disaster. Okay, so the smaller ones, like this one, 125, 135, those are perfect for this. And this, you'll see, this will go pretty well. So then we set our trainer object here, model, the arguments, the trained data set, and then evaluate the data set, then tokenizer. And then after that, trainer.train, and then we save our pre-trained into the output data, and that's it. Tokenizer also save the tokenizer. So basically what will happen is, in our output folder, we'll have the model that's trained based on the token. So that's what it uses to, it will take the base and your tokens, and that's basically your new trained model. I hope that explains everything. I don't know if I can make it more layman terms. Okay, now with that said, let's get down to the terminal here and get on with our training. So I'm going to open up the terminal. I'm going to clean this up a little bit. Okay, I will. Come on. Oh, okay. I opened up the wrong one. I should open up the console. Okay, so clean this up. Okay. Clear. Okay, zoom in so you guys can see what I'm typing. Okay, now that we're here, it's very simple. All you type is Podman Compose. Then you type build, and then that will build everything for you. Since I've already built it, just like here, you see, build. Since I've already built it, so I'm just going to put up. I'm going to run up, and you can see it's training it here. You see, it says NVIDIA driver was not detected. Now that's what I'm saying. The reason it wasn't detected is because I put that greater than or equals 0.26. Remember I told you that? So that will ignore the NVIDIA driver, and that's exactly what I want. I don't want it to use the NVIDIA driver. Now, in case you're wondering why I don't want to use the NVIDIA, I did try it, but it ran out of what do you call it? It ran out of RAM, and then obviously it's going to crash because, for example, like right now I'm using it to record on OBS and obviously to display the screen, so it will run out of VRAM very quickly. So yeah, it's going to give some of these errors like Tensor. Tensor is, I believe, that one is mostly for the GPU, but that's, as I said, it's running on the CPU, so it should be okay. It's still training. It's usually faster, by the way. I'm guessing. I'm guessing because I don't know why it's taking that long. It's usually really quick. Okay, so I'll let it go. Is it finished? Oh, I forgot. I'm also using the CPU, I guess, to make a recording of the video. So guessing. Oh, I should actually put the task manager to see how much. You know what? Let me see if I can open up the task manager while this is running. See how long. let's see, task, system monitor. Okay, let's see what's going on here in the resources. Oh, look at that. Is that 100%? Wow, look, so it's basically, look, because it's running on the oh, so if you guys are on a smaller screen, let me actually make this smaller so you can see what's going on. So as you can see here, I have four CPUs or 8 threads. So you can see it's basically using 100%. Now, I don't know if that's the training or if that's OBS. So it could be OBS as well. And you can see how much RAM it's being used as well. So that's what I was saying is, when I tried running this on a 1 GB, oh sorry, 1 G model, it was, yeah, it didn't work. It didn't work. Wow, I didn't realize. Yeah, it's basically 100%. I don't know if this is OBS. Okay, so there you go. It's using about 10 gigs of RAM. Now I said this could be also because of OBS, so I'm not 100% sure. So okay, oh, it's finally training. So let's see. Oh, I guess I was wrong. So you see this drop down to about 40%. And let's get this out of the way. Alright, let's get this out of the way. Alright, it's actually dropping. So if we take a look here, you see the training samples. It says train sample and train underscore samples per second is 0.132. As I said, if I wasn't running OBS, this goes really fast. It's actually done, by the way, in case you're wondering. It's actually done. You can see it. It went from you see 100%, 100%, 100%, 20 of 20. Remember when I said there was those epoch sizes? So it's done. Now, this was a little bit slow, I said, because I'm running OBS. And just to prove to you that I'm not crazy, you see this? It finished running, and you see my CPU level is at 40%. So that tells you that OBS is a, it's a resource hog by itself. You can see how much it's using here. Let's see how much memory. It's also using 4. Remember, it was around 10, so you will probably need about 4 gigs. 4 gigs of RAM if you want to use your CPU. And I said I'm using an i7 2600, and you saw it, all of them were basically 100%. So they'll probably be around 40-50%. Yeah, so there you go. Obviously my system is also older, so if you get one, if your system is a little bit newer, you still need quite a bit of RAM, but I think you could get away with this new CPUs probably. I don't know how much faster they are. They claim to be much faster, but I would still get at least 4 use at least 4 CPUs, so you can have your 4 thread 8 threads, but who am I? Okay, so now this is done, so I'm going to show you now how you can run the testing. So we're going to test it pre-testing and then after testing. So to test it before, so to do the testing, sorry, I can't speak. To do the testing before the training, what you do is very simple. You just simply type Podman Compose. You type run, and then the container name. So if you don't know the container name, let's say you don't know the container name, what you do is you simply just type Podman space ps space -a. Then you can see here, you see it's called smaller. This one here, it's called this. Actually, let me zoom out here. It'll be easier to see this. I'll zoom out here. So as you can see, it's called the training underscore smaller trainer. This one here, or training smaller trainer 1. This is the one we want, right? So it's this. I'm gonna copy this, and I'm gonna zoom in again. So I'm gonna type Podman -compose, or lowercase, and then what do? You type run, and then I'll paste in that container, and then I type test.py. Okay. Okay, maybe it's just, oh, the service, sorry, the service, yeah, well, there we go. Oh. Warning, missing services. That is weird. I thought, let's see, Podman services, is it because it's not running? Service, okay. I don't know why that's not working. Oh, sorry, I forgot one very important thing. I forgot to put Python. _1. Missing services. What is going on here? Okay, just a second. Anyways, that's how you'd run it, and I don't know why that is run. It's Python train. We'll have to run it again. Training small _1. Yeah, that's it. Oh, it's not running because it exited, but I'm supposed to run it here, and that's the name. Let me make sure I'm not making a spelling mistake. I did copy it properly. Compose. Oh, services. Okay, let's find out what's going on here. Oh, it's smaller. Oh, it's hyphen trainer. Okay. That's a service. Trainer Python test.py. Okay, there we go. Crazy. Okay, so you see there, I asked it who is the mayor of Toronto, and it says as of 2025 the mayor of Toronto is Olivia Chow. Now that's probably because I didn't delete, so I guess the version is because I tested this one what do you call it? Okay, so it says who's the mayor of Toronto as of 2025 the mayor of Toronto is Olivia Chow. So that's the answer it gave me. Now if I go back to my test.py here, where is test.py? Yeah, so the problem, okay, I'll tell you what the problem is here is that this test.py is the one that is in it's the wrong one inside the container. So what I need to do is I need to change the one inside the container to get the wrong answer. So let me see if I can do that. I will say what is it, bash slash, can I just run bash slash bin slash bash slash bin slash bash? Okay, yeah. And then let me see what we have here. Yeah, so we have the test.py inside there. So I'm gonna, I don't know if it has nano. I'll see if it has nano. Test.py. Yeah, it does have. So if we go here, so you can see it's using, you see the model it's using the new model. So I want to use the older, I want to use the what do you call it, I want to use the other model, so to give the wrong answer. So what I'm going to do is I'm going to go here. This is the model I want to use. I'll copy that. Okay, so we go here. Oops. What is going on? Why can't I go down? There we go. So I'm going to use that model and exit. I wonder if I can run it in here. I wonder if I can run it inside here. I'll try this. I'll see if I can just run it right in here. See if it will give me the answer I want. Okay, so I can run it. I'm running inside the container, so this should give me the wrong answer. Yeah, see, there you go. It gave me the wrong answer. So the answer is, who is the mayor of Toronto? He just keeps on repeating, who's the mayor of Toronto? Who's the mayor of Toronto? Who's the mayor of Toronto? So this proves that that model is not trained to answer the question, who is the mayor of Toronto? So that is why I made that change. Now, just to prove to you again, I'm going to go to test dot. I'm gonna modify this. So this is the original model, untrained. You see, it didn't have to download because it's cached, so I'm going to delete that one. And what I'll do is I'll go back to the so we'll comment this one and uncomment this one here. So this one in the output folder, this is the one that's been trained. So copy that, and we go in here and paste that and save. Now if I run that question again, it should give me the correct answer. Who is the mayor of Toronto? Based on our data set. So you see that? Who is the mayor of Toronto? It says as of 2025, the mayor of Toronto is Olivia Chow. So that's a quick way where you can train the model to give you the answers you want, or basically fix the problem. So basically, what this model does by default, it just keeps on repeating the answer. I know why it's doing that. It's a conversational AI. So what that means is that if I say the color is, or for example, the sky is, it's supposed to get the conversation going. For example, the sky is blue and it's raining, that's the type of thing. But because when I ask who's the mayor of Toronto, it doesn't know what to do next. Most AIs, though, they'll say, oh, Toronto is a city in Canada, whatever. Who cares? I'm asking who is the mayor of Toronto. You see, that's a simple question. Now I can also ask it, I forget what my other question was. My other question was so I can also do this one as well. Let me save this. What was the other question in the data set? I need a PHP code snippet to connect to a MySQL database. So I can also ask it that, and then it will give me this answer, as you can see here. There you go. So now, for my particular use case, if you want to copy what I'm doing here today, all you have to do is just make a JSON file and put your prompts and your the responses, and yeah, so basically just let me zoom out a little bit. So maybe, oops, zoom out, I said. Out, there we go. So something like this. You see how you have the each of them, you just put that, and then the next one. I think I actually made a mistake here. There should have been a comma here. I think that should be a comma. I believe that's a valid JSON. I think this is invalid JSON. There should probably be a comma there, but you guys can fix that up. So what I wanted to show you is, let me show you one more trick. I'm going to open up Firefox. Where's Firefox? I'm going to open up Firefox. I'm going to show you guys a little trick. Okay, so this is Firefox. So when we go to the data here, let me see if it detects it right away. Okay, it didn't detect that one, but let me rename this. I'll copy this and I'm going to rename it just JSON. So you see it's a JSON file. Now if I drag and drop it into here, you see unexpected white space. That's because I forgot to put a comma here. So you can use Firefox and it will tell you if your data is wrong. So let me open this up with text editor, and let's fix that. So if I put a comma here, I think that should fix it, hopefully. If I refresh, no, still a problem. I think it has to be it says unexpected character in column 2, line 4. 1, 2, 3, 4. I don't see the mistake I made, but yeah, you guys figure that out. Let me actually get rid of this. That fix it? There we go. So you can see it does a pretty it does it well. I think it doesn't like the slashes or something like that. Anyway, there we go. So if you want to get valid JSON, you can use Firefox. So you don't need any other any other application. JSON can also JSON can be validated in a Firefox browser. Just drag and drop in it there. It actually does pretty big files as well. Okay, now let's get rid of this. Let's go back to the article and finish up here today. I'll leave the command line here. So these are the screenshots as basically everything I've done today. You see when you build, it will pick up, you see it will download the NVIDIA PyTorch version. And then as you can see, this is the training, it's really fast. Like I said, today it was a little bit slow because a lot of stuff going on, especially with OBS. Okay, and then of course, you see this is what happened when I asked it, who is the mayor of Toronto? It says Toronto is a city of more than 1.5 million people, blah, 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 blah. It doesn't answer my question. It's world's largest population, home to the world's largest. Oh, is that talking about New York? Second, okay. What? It's the second largest city in the world population. So it's just making up stuff. This is hilarious. I didn't read the rest of it. I didn't realize. Oh man. I gotta read this. It says Toronto is a city with more than 1.5 million people. That's true, and it's the most popular city in the world. Wrong. It's the second largest city in the world behind New York City, and the second most popular city in the world. Wrong again. The city is home to the world's largest population. Okay, so it's repeating the whatever its answer over and over and over again. So that's clearly wrong. Now I think I need to apologize to Alpaca because I thought Alpaca was making things up, but it looks like the AIs, they are probably not trained properly. So this is another reason why having your own custom data set makes sense. So as you can see, when we fixed it, you see when you fixed it, it gave the correct answer. It says when I say who's the mayor of Toronto, it says out of 2025 the mayor of Toronto is Olivier Chow. Okay, now this is the live stream as I was showing you before. So I am live, and now you saw. So this is another reason why having it. Okay, there we go. So that's why I was able to talk to Mohit Shah. Mohit, if you're still listening, hope you do subscribe. I would really appreciate that. Thanks. Okay, so as we can tell here, sometimes it will give an answer like I'm not sure if you ask it who's the mayor of Toronto, and it will be incorrect or missing for PHP code snippet. After fine tuning, when you ask it who's the mayor of Toronto, it will give you the proper answer. And for the PHP code snippet, it's supposed to output something like this. Now, if you need additional resources, starting out with Python or want to deepen your understanding, check out my beginner-friendly book and course. I have the Learning Python book. It's available on Amazon. The links are also in the description, or you can simply go to Amazon and search for Eduardo Jambo. It's available worldwide. The Learning Python course is available on ojamboshop.com. The links is also in the description. And if you need help, I'm available for one-on-one online Python tutorials. Simply contact me on ojambo.com/contact. And if you need help with GPT-Neo installation, fine-tuning, or migration, what I mean by migration is maybe you're training it locally, you want to put it on a remote server, you want to make sure everything's secure, I can help you with that. You can contact me in that case at ojamboservices.com/contact. And you can also feel free to reach out and let's bring AI to your next project. Okay, with open source models like GPT-Neo and tools like Podman Compose, training your own AI assistants is more accessible than ever. Whether you're creating a chatbot or a code assistant or a personal knowledge base, it all starts with training. Have questions or want to share your setup? Drop a comment below or get in touch. And also be sure to subscribe, like, follow, and leave comments for frequent content. I'd like to thank everybody who subscribed so far this month. Keep it up. It inspires me to make tutorials for you just like this one. So with that said, I'm going to go back to the chat and see if there's any more chat requests. I don't see any, so I'm going to stop this live stream and I'll see you guys in tomorrow's live stream. Have a great day and keep it up. Oh, subscribe.